I'm going to quickly illustrate a number of commands that are available in R, and I'll give you a summary sheet about these as well. The first command I'd like to refer to is one called the combine command. It's a function. You write it like a function. The C calls the command. You just put a list of elements in here, as many as you want. It might be a list of data from a sample, for example. And what this combine does is it makes a vector out of that information. Since I didn't say anything to do with this vector, it went ahead and printed the values of that vector out, the 2, the 3, the -4, 5, 6, and 7. I'm now using the up arrow button. That's a nice feature of R, is that you can recover commands that you've previously typed in. What I'd like to do is create a vector called v1 and have that vector stored in that variable v1. Now notice it didn't put any output at that particular point, because what it did was store the output in v1. But at any time that I want now from here on, I can type v1 and be able to see the contents of that vector. I can also do an ls. It's a function that's looking for a list. If I look a list with nothing in the input, then it shows me all of the variables that I've got at any particular time. I'd like to build another vector. We'll call it v2 for right now. Maybe, let's try something else just real quickly. Suppose that I looked at the length of v1. That's really kind of handy. It tells you how many, it's the n of the sample essentially. It tells you how many elements are in that vector. So this vector has a length of 6. I'd like to create another vector v2 just for illustration purposes. Now I'm making a mistake here on purpose. 1, 2, 3, 4, 5, 6. Notice that when I do that, it gives me an error. There's something that's unexpected here. Do you see what it was? I'm pressing the up arrow key to pull that back. I needed to tell it to combine those elements into a vector. So now I've got two vectors. Let's look and see what we've got. We've got vector 1 and vector 2. Anytime that I want to look at vector 2, I can. Anytime I want to look at vector 1, I can. I can take these two vectors and add them together. I can take these two vectors and multiply them with each other. All of these operations, of course, v1 times v2. There wasn't a vector 3, so I couldn't do that. But it does these operations component-wise. Another nice feature that we'll want to use often is called the summary. We can do the summary of vector 1, which gives the 5-number summary of that particular list of numbers, the minimum, the maximum, the first quartile, the third quartile, the median. It also calculates the mean. There's also a function that's called mean. In this case, the mean was 3.167. There it carries the mean out to a few more decimal places. Another interesting feature is that if I took a vector minus some particular number, suppose that I subtracted the mean from the vector, then component-wise it subtracts that mean from each one of the individual numbers in the list. We've done some things with that before. Suppose that I took that particular amount and then squared that vector. That means it'll go, what I meant to do was square that vector. Notice that it goes along, takes each one of these values and squares them. Not only that, if I took that particular amount that I had just calculated, which is a vector, and look at the sum of that vector, then it just adds up all of those values. Now that particular number is an important number to us in the past. We've called that the sum of squares. The sum of squares of let's do it this way. I'm just pushing the up arrow button again. I want to store that as the sum of squares of v1 equals. So now when I look at the objects that I've created so far, I've created this sum of squares of v1, v1, and v2 so far. What did we use the sum of squares for? Let's see, that was for calculating a variance, right? So if I took the sum of squares and divided it by, let's see, the sample variance was divided by n minus 1. So what I need here is the length of vector 1 minus 1 is what I'm going to be dividing by. Aha! That particular value is the variance of v1. Oh, but there already is a function actually called the variance of v1. Notice that of course we get the same value there. Okay, let's stop at that point and we'll show some more things in another video.